Now that we've talked about position, we can start talking about changes in position, which will be important about talking about motion. A change in position is called a displacement. Just a technical term for it. Displacement is the difference between a final position and an initial position, right? Which they then flag here that a final position to the left of the initial position would give a negative displacement. For instance, look at this movement. We would have that the change would be 0 feet minus 50 feet, which of course is itself minus 50 feet. So the displacement is negative. In general, because we symbolize displacement with delta x, in fact the symbol delta we'll talk about in a second is an important symbol in physics, and we define that delta x is the later moment minus the earlier moment. Your book says final minus initial, and that's fine. I am not happy, or I don't really love that, because it acts like it's this gross metaphysical final, the end of things. We really mean comparing two moments. One of them will always be later and one of them is always earlier, and the displacement between those two moments is always the later position minus the earlier position. By the way, the picture there is not well done. So for this motion, it would have been the thing which started here, and ended up over here. That's this motion. We use the Greek letter delta, it looks like a triangle, to represent the concept change in. And since x means position, delta x then reads as change in position. You can use delta for any sort of quantity. Here's the important bit. Delta is always time ordered. It's always later minus earlier. So delta x means later position minus earlier position. And you might have delta dollar signs, which is money I have now minus money I had before. Delta is always later minus earlier. In order to quantify motion, we'll need to consider changes in time, which we call time intervals, because we're not, super creative. I often call this, and this is my own term that no one else seems to use, I call this a duration. So a motion has a displacement and it has a duration. So delta t, a time interval, measures the elapsed time as an object moves from initial position at time ti to a final position at time tf. And again, the i's and f's are a little risky. They mean the initial and final of this interval. You could have a problem where you have multiple intervals. It doesn't always mean the absolute beginning or absolute end, but just the interval you're talking about. And we can see that delta t is always positive. Let's talk a little bit about why that's the case. Let's talk about negative time. T by itself represents the time on a clock, really the time on a stopwatch. Not so much, it could be a time on a clock, but we don't usually think of it that way. But it's a thing measured by a stopwatch or a clock. All right? You can imagine a stopwatch combined with a countdown timer. We have to pick some moment as the 0 time on that clock. We've got to, wherever we reset the stopwatch. All early moments then become negative time, negative values of time, since they occur earlier than earlier. And we define earlier as being lesser clock time, right? The way we can order, if I put a bunch of numbers out there and I say moment A happens at 3 seconds and moment B happens at 1 second and moment C happens at 8 seconds, and I say which of those is earliest and which is latest, you can easily say this is earliest and this is latest. And we know that because 8 is more than either of the others and 1 is less than either of the others, because that's what we mean. I don't want to overstress this, but what we mean by earlier or later is an earlier time has a lesser time value, has a value on the clock that is a lesser number. But if we have a 0 moment and something occurred before that 0 moment, well, then it has to be a time less than 0 or a negative time. Don't freak out about negative times. A lot of people the first time through get all worked up over the idea of negative time, and they think of like Star Trek or Doctor Who or something. But here it's just an accounting, right? We're just trying to order things, and it just happens there earlier. This would be something like saying if your paper is due at midnight and it's currently 11:45 p.m., then you're at minus 15 minutes, right? You're 15 minutes until it's due. All right, strobe photographs. In each case, a sphere is moving from left to right next to a tape marked in meters. A strobe flash photograph is taken every second, and the location of the sphere is recorded. Total number of time intervals shown are not the same for the number of spheres, obviously. Draw a blue circle around the letter or letters with the greatest displacement during the first 2 seconds, and a red circle around the letters with the least. So let's highlight the important bit during the first 2 seconds. Because of that, we should probably figure out what those are. So for A, 0, 1, 2 seconds, 0, 1, 2, 0, 1, 2, 0, 1, 2 seconds. And we want the greatest displacement, which is pretty clearly, this one, because that displacement is 8. And the least is pretty clearly this one, because that displacement is only 1 during those 2 seconds. Carol is enjoying a bicycle ride on a country road that runs east-west past a water tower. Define a coordinate system so that increasing x means moving east. At noon, Alice is 3 miles east of the water tower. A half hour later, she is 2 miles west of the water tower. What is her displacement during that half hour? Although it's kind of overkill, we should always basically start by making a drawing. This is a general rule in physics. You don't have to draw something every time, but life is usually easier if you have a picture in mind. So we draw the picture drawn here. Here's our water tower at 0. Here's Carol at the start. Here's Carol at the end. Clearly, delta x points from here to here. We have values for our initial and final positions, so displacement is very simple. Always delta x is later minus earlier. She ends at -2. She starts at 3. -2 miles minus 3 miles is a total of -5 miles. Is that reasonable? Well, she moved westward, so she certainly have a negative displacement. Should it be 5 miles? It's hard to say if that's reasonable or not, but sure not. 5 miles in half an hour is reasonable for a cyclist. We try and make the problems physically reasonable. It's worth asking that question. That's not too bad. 10 miles an hour for a cyclist isn't too bad. Maria is at position 23 meters and then undergoes a displacement of -50 meters. What is her final position? So let's draw a little picture. Here's the origin. Maria starts at 23 meters, and then she goes from here. She goes a displacement of -50, so she goes -50, and she ends up here. And we might say delta x is x final minus x initial, which means x final is x initial plus delta x, which, let's take a second to comment on that. It says where we end up is where we started plus how much we moved. Duh, but that's exactly what this says. Where we end up is where we started plus how much we moved. So it's useful to think of delta also, it is the change in position, but you can also think of what did I add to get my final position. Now we can just go put in some numbers. She was at 23 meters. She has a displacement of -50, so she ends up at -27, which is answer A.